Hello everyone. So let's solve a question from radius of curvature of projectile. So this question is, a projectile is thrown with initial velocity u at an angle theta with the horizontal. Find the radius of curvature of the projectile at a point where the velocity vector, where the velocity vector is actually making an angle theta by 2 with the horizontal. So let me just take an example like a projectile. So as you can see, I'm just drawing a projectile here. So initial velocity is given u, and it makes an angle theta with the horizontal. And at a point, let's say there is a point where the velocity vector is making an angle theta by 2 with the horizontal. At that point, we want the radius of curvature. So I'm just giving, this has to be horizontal, correct? Yes, this is theta by 2. Okay, so the idea we know very well, that is here g vector. So as you can see, the g acceleration g is acting downward, and I can make the two components of g as well. We already did it in the last video. So what is that? If this is theta by 2, then this will be 90 minus theta by 2. Then again, this will be theta by 2. Okay, so I can take two components for g. Here, very clearly, I can take two components. This is g cos theta by 2. This is g sin theta by 2. So one thing, it is very clear. Here, you can see g and v. Look at this. G cos theta and v, they are perpendicular to each other. So at this point, they make a circle. It makes a circle. And that circle is fundamentally the idea. Look at this. That circle, from that circle, you can get the radius of curvature. So we already discussed velocity square divided by radial acceleration is what is radius of curvature. So R is equal to, what is the velocity? V square divided by g cos theta by 2. Okay. So now let me ask you a question. So if this is the thing, velocity, I don't know how much is the velocity. So I have to find out that. But one thing I know, that at this moment, I can just show it here. This is v, and it makes an angle theta by 2. And I would like to take the horizontal component of this velocity and vertical component. So how much will be this? This is v cos theta by 2, and this will be v sin theta by 2 at that point. And one thing I know, that this will be equal to v cos theta by 2. That means fundamentally this one will be equal to u cos theta. Why? Because horizontal component of velocity will be always same. So I can substitute that there. V cos theta by 2 is equal to u cos theta. So I can say, what is my v? V is equal to u cos theta divided by cos theta by 2. Substitute in the equation. So R is equal to v square. What is v square? This one. U square cos square theta divided by cos square theta by 2 divided by, so what is there? G cos theta by 2. G cos theta by 2. So what is the answer? Final answer is equal to u square cos square theta divided by g times cos cube theta by 2. So this is the radius of curvature equation. I hope you understood. Very simple, very simple. And if you haven't got it, you just go through the steps again. And the idea of radius of curvature of a projectile, I have given in the last video. So you can check out that as well. Okay. So one more thing. See, like we already learned one thing, that radius of curvature has like a calculus equation, differentiation equation as well. What is that? 1 plus dy by dx the whole square, the whole raised to 3 by 2 divided by d square y by dx square. And also we know the trajectory, the yx equation of projectile. This is like little exaggerating thing, and it is not at all required for us. But I'm just giving as a practice. I'm just giving as a homework. So I want you all to try. So we know the trajectory equation, y is equal to x tan theta minus half g x square divided by u square cos square theta, or gx square divided by 2u square cos square theta. So this is the fundamentally the trajectory equation of a projectile. I want you to do find dy by dx, find d square y by dx square, and at look at this at theta is equal to angle is equal to theta by 2. That is very important. And then you substitute here and you check whether you are getting this answer or not. I swear you will be getting the answer, and you try. All of you try, and you must be thinking that sir, square and all the 3 raised to 3 by 2 and would it be getting? Yes, you would be getting, and we will see in the next video. And what you exactly, I mean, did you really get this video? I mean, the answer or not? You just comment below. Okay, thank you.